enjoy this. Please.
Okay, well, thank you very much for that introduction, and thank you all for attending this session. I know it's getting later in the evening there, and it's early in the morning here in Australia, but I'm very pleased to have this opportunity to speak with you about what I consider as a very important topic. This is a detailed topic. You know, this is something we could talk about for a few days to really get into the details of how to end reactive maintenance. But I think that in this time that we have together, we should be able to cover all the most important points. I'm not taking a particularly conventional approach to this. I should say I've been involved in reliability improvement for many years. I originally got started way back in 1984. And, you know, part of the challenge in this industry is there are a lot of people who are passionate about their particular part of the reliability improvement journey. And that's great. We need specialists in different areas. And, you know, I've been a specialist in vibration analysis, you know, for a long time in my early part of my career. So everyone has their experience and so on. What I've been trying to do, you know, for the last 10 years or so is really try to bring it all together and say, well, how is it that we can successfully improve reliability in the plants? Because there's a lot of companies trying to improve reliability. There are a lot of companies that suffer from the problems associated with poor reliability, you know, from downtime and high maintenance costs to production issues to safety and environmental issues and lots of others. Anyway, let's get started. Please, if you have any questions or you want to challenge anything that I say, please feel free to write it down and we'll address it at the end. So you may be asking, what is this dramatic thing, this reactive maintenance cycle of doom that we're going to try and break out of? So let's just look at it with a simple sort of an animation. The fact is, now again, this presentation is addressed to you if you are suffering unexpected failures that you would rather not suffer from, where the maintenance department is forced on most days to deal with some problem that's popped up. So rather than planning and scheduling, you know, a couple of weeks in the future and having a condition monitoring program that's telling you what's happening, you know, months and even a year from now, and having very high reliability and so on, this is for what I well know is a very common situation out there where we are suffering from preventable failures. And that's one of the things we could talk about for a long time. But a lot of the failures we experience are actually preventable. So that has, you know, that's our reality. The trouble is then that resources are taken by those breakdowns. Rather than being able to focus your time on the proactive things that we all know we should do, there's just no time because of these constant failures. Oops, a daisy, my apologies. I have to just click those buttons again. So we have the preventable failures that occur. We have resources taken by those breakdowns. And then what inevitably happens is we're in a rush. We aren't necessarily able to use the people with the highest skills to do a given job. You know, production is stamping their feet saying we need the equipment up and running. So the repairs and the installation and so on aren't necessarily performed to the highest standard. There may even be a feeling like, okay, look, let's just get it running for now. We'll get back to it later, which of course later never happens. So there's lots of repeat work because maybe we actually do try to do something about the problem later, like do a precision alignment or, you know, whatever it may be. But often it's because the failure occurs again soon after. But no root cause failure analysis is performed to truly understand why the failures are occurring. And so very little is done to eliminate those failures. So therefore, when suggestions for improvements are made, they're ignored. People, it just might be a cultural issue that everyone is so focused on just keeping the plant running that there just isn't the time and the interest in trying to solve future problems. Well, there's a number of reasons why this can happen, but even if the suggestion is a good one, they might say, right, we will get to that when we have time. But of course, there is never time. And we're in this cycle, and that's the problem. And so management are seeing these very high maintenance costs. They're seeing the reduced production output. Financially, that's a problem. And they say, well, we have to do something. We have to keep the organization running. So they decide that the most obvious, quote unquote, obvious thing to do is to reduce the headcount, to fire people. And they look at the maintenance department as an easy target and say, well, we'll just remove some people from the maintenance department. But of course, that only makes the problem worse. Now you've got fewer people to do the work. So the natural situation then is morale declines. Everyone feels very unhappy with the situation. They start to feel that their job might be at risk. They're seeing their co-workers being fired. Their suggestions aren't being listened to. They know many of the reasons why the equipment's failing, but nothing's ever done about it. It's just this nasty cycle. So standards can drop even further. I mean, when people aren't motivated, when they're not listened to, then the work that is done is often done at even a lower standard. And this isn't a deliberate thing. This is just people being human, being demoralized, not being happy with the situation. So the jobs that are in the backlog, the jobs that maybe if there's any sort of planned work because of warranty requirements or statutory requirements or something like that, that work isn't being done. All the requests for, you know, minor and major repairs, they're backing up. It's like a huge weight on the shoulders of the people in the maintenance department. And as a result, those PMs, some of which, and let's even say many of which, are really necessary to keep the equipment running in tip-top condition. So we have this cycle, and it just gets worse. It just keeps going round and round and round. We have more preventable failures, and resources are taken by those breakdowns, and repairs are performed poorly, and it just keeps going round and round and round. And you may attend sessions like this and attend conferences and read books about all the wonderful things you can do, but you go to work and it's another day taken up with reactive maintenance, another week taken up with reactive maintenance. By the end of the month, you're saying, I just don't have time to do those things. There's just never time. How, you know, it's all these wonderful suggestions you're hearing about lubrication, about maintenance strategy, about planning, about all these things. It's like, they're all great suggestions, but I just don't have time. And that is why I call it the reactive maintenance cycle of doom, because it is, unless you've got a plan, really difficult to break out, to get the time available to do what you know you've got to do. Now, saying all of that, the problem with our industry is that we have a lot of people, and I don't mean anything terribly negative with this, but people who are passionate about their particular areas, or people who just say, well, this is what you need to do to improve reliability. And of course, the list is long, but it includes, of course, doing wonderful things with condition monitoring, analyzing reliability data, performing reliability-centered maintenance, planning and scheduling, and so on and so on and so forth. And you can see a list there. But how many of those should you do? And should you do them all? Because there's certainly a lot of voices out there that just say, hey, here are all the things you've got to deal with. There's so many of them. And the basic message is, well, if you just go and do all those things, your problems will all be solved. all the condition monitoring technologies, everything. There's a nice long list of those things. And the message is just go do it. Well, again, you get to work. It's like, I'm just going to go do it. That was terrific. Wow. Now I know all the things that I should be doing that I'm not doing. And the result is that you just don't have time, so you don't get to do anything. Or of course, then there are the people who say, well, if you just do what I say you should do in my special area, because if you just take care of planning and scheduling, well, your problems will be solved. Or just spares management, or just RCM, or just condition monitoring, just vibration analysis. No, root cause analysis is the answer. Oh, lean, you should get into lean. And as I say, it's terrific that we have people who are passionate in those areas, but the message should be that this is one piece of a much bigger puzzle, and that it is a real problem if you try to go from zero to hero in just one area without dealing with the other areas. Now, I could spend a long time just talking about this because I see this problem all the time. People have wonderful skills in condition monitoring, but no one listens to their recommendations. They're saying, hey, why are you telling me about this bearing that's going to fail in many months when we're having enough failures every day? I mean, why are you trying to give me this massive asset strategy? We don't have the culture, the skills, the planning, the organization, or anything else to do those things. So it's not to say that any one of them is bad at all. It's a case of how do you step by step transition out of this process to defeat the reactive maintenance cycle of doom. So my feeling is that you need a coordinated step of activities, plan of activities, where you seek to become good in certain areas, better in some areas, not as good in other areas. Just get started in some areas. But in order to be good in condition monitoring, you need planning and scheduling. You need to do some RCM so that you can be good in condition monitoring. You need to do some root cause analysis. You need to do lubrication if you've got rotating machinery. And I could go back and forward through all the areas. They all feed on each other. We need to slowly grow each and every one of them and not get drawn into this idea that we have to be superheroes at everything. We have to be perfect at everything. I can just say, after all these years being involved in this field, there are so many companies that have lost so much time and so much money trying to be superheroes in just one area, and everything else is weak. We just can't do that. So the idea is that we become good in certain areas and then build from there so that we can be great in all those areas. That's terrific. Now, for what it's worth, and there's lots of free information about this and very inexpensive about this, we do have a process called the asset reliability transformation that can help you go from whatever your situation is now all the way through to, if you want to call it a world-class reliability program where all of those pieces and more are all functioning well together. And so we could spend a lot of time talking about that, but that's not that's not the focus of this presentation. But all I can say is that we've tried to break that down into small pieces you can do step by step. And there's 365 steps, and each of those steps are actually quite detailed. Now you might think, oh my goodness, 365 things they're going to ask us to do. Well, if it was easy, you would have done it by now. If it was easy, the majority of the organizations out there around the world would have reliable plants, but they don't. There are a lot of things you need to do, but you can do them one step at a time. And so we've broken it up into 64 major steps, and there's the major steps, and they're all timed and coordinated. And anyway, my point for this presentation is that reactive maintenance is a huge roadblock. And if you can't get past this, you will never truly get the plant singing the way it should. You won't have a reliable plant unless you can overcome reactive maintenance, because it will just keep sucking you down, wasting your resources, getting you frustrated and upset. So the message is we go from average, whatever your situation is now, to good, and then we can go from good to great. So one of the steps of this asset reliability transformation is the control step, controlling maintenance, getting things under control, not getting things to perfection, just getting things under control so that you get some breathing space so that you can slowly crawl out of that cycle that we were looking at and move forward. And so some of the steps are associated with that, and they're timed, you start this one, then you go on to this next one, and so on. So I will talk about them sequentially, but just understand there is overlap between them. You do a bit here, a bit there, etc., etc. And there's 78 sort of individual things we're going to ask you to do to break out of the reactive maintenance cycle of doom. But obviously we don't have time to go through all 78 here. For what it's worth, there is a book I've written to try and explain all this stuff. If this presentation, we don't have time to go into all the details, a book is a very inexpensive way to learn about all of this. Okay, so yes, it might sound like I'm selling a book, but seriously, I mean, it's so inexpensive. It's just a great way to move along with this journey. You don't have to get all the training if you don't want to. So reactive maintenance is like dealing with a fire. It's great to have good firefighters, and maintenance people can all be very proud of the fact that they come in at 2 a.m. in the morning and get the machine running again. And there's certain people with terrific skills. They can find out what's going on and get the machine running. But our goal has to be to have no fires. It's great to have good firefighters, but it's not good to have fires. And if you know anything about fire, you've got to either starve it of the fuel that it's burning, you need to starve it of the oxygen, or starve it of the source of heat. So what we're going to be talking about today is addressed towards this concept that we need to stop the fires from starting. We do need to be good at fighting the fires, because we're going to do it in such a way that we don't fuel the next fire. A lot of the problems is, people come in to do that emergency work, and whether it's emergency work or just the normal work during the day, the trouble is they leave the equipment in a state where it is going to fail prematurely. It isn't going to run for the next 10 years. It's not even going to run for the next 10 months. 10 weeks would be great. 10 days is often what happens, or less. So let's get on with it. So as I mentioned, there's a lot of major steps. I'm going to talk about some of them a little more than others. So the first thing we need to address and make sure we have right is that the operations and production, if you're produce something, and the maintenance group have to be on the same page. We can't have this combative thing where the operations people cross their arms, blooming maintenance people, all they ever do is stuff up our machines, and if only they did their job properly, we could keep running this plant. And of course, the maintenance people have their arms crossed and say, well, if you could just operate the equipment properly and didn't stop and start it the way you do, and didn't operate it different ways and stress and strain the machines, maybe we would have fewer failures. We've got to stop that arm wrestle. We have to have cooperations and mutual respect. So one of the things, and again, I'm not going to go into all the details of how you achieve this, because we would be here for a lot longer than an hour to go through all of these areas. But the maintenance department has to understand that their actions do impact production and operations have to understand how their activities and actions affect the maintenance department. There has to be a mutual awareness and a mutual sense of cooperation to say, together we can beat this. So this is, without that in place, anything else we talk about is going to be difficult. It's very hard to have planning and scheduling, for example, if the operations aren't cooperating and don't want you to take out machines before they've actually failed, and so on and so forth. Okay, next thing. We need a way to prioritize our activities. You may be able to look out your window, well, it's 9 p.m. where you are, so probably not. But visualize your plant. There are so many pieces of equipment out there. where are you going to focus your attention? Now, a little analogy. If you were the headmaster of a school and you said to all the teachers, we have a discipline problem here. We have damage being done to school equipment. They're letting down the tires of our cars. Things are a real problem. What would you do? Would you start at the students with names that start with A and work all the way through to the names that start with Z or Z, and systematically go through and try to do something about it and treat every student the same? Or would you identify which of the students actually cause all the problems? Which of the students that go out there and set the cars on fire and destroy materials and hold teachers to ransom and whatever? You're going to deal with the bad actors or the bad students. Well, we are the same. We've got a plant. We need to know where our risks are and meet them head on. So there's a few ways we can do that. But the main issue is we want to find out which pieces of equipment consume your time and your money. And if we can focus on those, we will do a lot better than just trying to overall deal with all the equipment you've got. So one way is to find out which pieces of equipment have been causing you the greatest grief. And the other one is to look at, just perform risk analysis. So 3 ways we can do it. Pareto analysis. And you might have heard of a bad actor list. Pareto analysis, the theory behind Pareto analysis is that 20% of your assets, pieces of equipment, cause 80% of your headaches. In reality, it's probably 1 or 2% of your equipment cause almost all of your problems. So instead of looking at your plant and treating all your equipment equally, if you knew which were the 1% and focused on that, you will be amazed how quickly things can transform. So we're going after the bad actors. If we take this approach, we can, with the right data, and I'll come to that, and it's also a bigger topic, but we can find out which pieces of equipment fail most frequently, which may be different to the equipment which causes the most downtime, which costs the most to repair, which take the longest to repair, which have, and what type of components is it? Bearings, gears, electrical switch gear, what is it that actually fails most frequently? There's lots of ways that we can hone in on what's actually causing us the problem so that we know where to focus our precious resources. We don't have much time. We've got to use it well. So Pareto analysis is a very simple way of doing that. Another way, which I recommend you do in parallel, is you perform, to begin with, a simple criticality analysis. Criticality is the combination of the consequences of failure, the likelihood of a piece of equipment beginning to fail, and the likelihood of detecting that failure. So of course, at one extreme, if you've got a piece of equipment that if it failed, it could cause injury or lengthy downtime, or it requires very expensive parts to repair it, well, the consequences of failure are high. But it might be that with some of those equipment, you say, well, actually, yes, the consequences of failure are high, but it's been running for the last 10 years without problem. So the likelihood of beginning to fail, developing some sort of fault condition like a bearing fault, that contributes to the risk that we face. And then there's the question of the likelihood of being detected. In a great condition monitoring program, we might have equipment that is that has a high consequence of failure and that isn't very reliable and might frequently begin to fail. But if we have a great protection system or a condition monitoring system, the likelihood of detecting it and thus dealing with it ahead of time is very high. So we can go through and numerically score our equipment and determine which pieces of equipment pose the greatest risk. And then, we can focus there. The third thing you can do, and this is particularly true if you don't have a lot of data to work with to do the previous two, but as I say, there are ways of doing that if you've never recorded anything, but unfortunately we don't have time to get into all the details here. But the other thing to do, whether you have the data or not, is to sit down with your crew and discuss this. It's part of the culture change process. It's a part of being inclusive. It's a part of saying, hey, I understand you maintenance people and you operators. I understand that you've experienced these failures all the time. That you understand an awful lot about the equipment. We need your opinions. We need your thoughts on, well, why the equipment's failing, but what equipment fails and what warning signs you see and everything else. We need to involve as many people as we can. But I also recommend that you go out in the plant and you just spend some time observing what's going on. You can't solve reliability problems from your office. You've got to frequently be out there, talk to people, ask them questions. Make sure they don't fear you. Make sure they don't think, oh, God, there he is. He's checking up on me. No, you're there to learn from the people, what's going on. But you can observe the maintenance work. You can observe how the storeroom is working. You can observe everything that's going on and see for yourself what's going on. Where is the waste? Where are the problems being introduced? Do you see maintenance people running over here to get this tool, you're running over there to get that part, waiting in the storerooms, doing this and that, and they finally sit down for 5 minutes a day and actually do some work? It's like, we have a problem here. We have people with skills that aren't using them. So these are problems we need to address. You can't solve problems if you don't actually understand what the problems are. Okay, so there's a lot I could talk about in all these areas. I have to sort of stop myself. The point is, I guess, that I think one of the steps is to sharpen your focus. There is an intersection, so to speak, between what are your critical assets, what are your bad actors, and if you have any form of condition monitoring in place, which equipment has poor health. If you can focus in that area there and just say, I need to stop these pieces of equipment from failing in the future, just that equipment there, then we can widen that circle. We deal with the worst cases where we have the greatest risk and the greatest likelihood of failure and downtime and the costs associated. We deal with those and then we broaden the circle until that circle covers, well, potentially everything, as long as we're not wasting our time. But we just need to start with laser sharp focus. All right, solving the bad actors. You might be listening to this saying, oh, it sounds wonderful, Jason, but how do we solve the bad actors if we just don't have time? Remember the reactive maintenance cycle of doom? We don't have time. So here's my first controversial thing to say. Perhaps it's controversial, perhaps it's not. What I'm going to suggest is that you take one person out of your maintenance crew, and it all depends on the size of your maintenance crew. You could use more than one person, but you say to that person, you must never do reactive work. We're going to identify all kinds of tasks that are being performed to extend the life of the equipment, to stop the failures. And that person, unless the sky is falling, they will only do that work. Now, that might include lubrication work and certain cleaning work, but it'll be proactive maintenance tasks that avoid future failures. If you don't pull someone up aside and even create a separate department so that people can't just say, oh, sorry, you need to stop doing your future work and start dealing with today's problems. The more time we can spend on those future problems, the less problems we will have. Okay. Now, I said one person. Consider rotating people through that role and slowly growing, that team from one person to 2 people to 3 people. But, might be for the next month or 2, one person does it, then the next, month or 2, another person does it. Everyone, when you start changing the culture, everyone is going to want to be a part of this, and everyone should have the opportunity to do this work rather than just the annoying reactive work and potentially dangerous reactive work. Now, a manager might say, well, this all sounds great, but I don't know about this, So one little trick is, look, give me 90 days. Just give me 90 days to do this as a trial, and we'll see how it works. In 90 days, you will see the benefits, and the manager will say, yep, keep doing it. not a problem. All right. So we want to focus on those issues. We're going to use one person to start doing the proactive work to avoid future failures. You might think, well, hang on, we're going to lose a person. I'll come back to that. You do need some sort of basic computerized maintenance management system. Now, you might have a great system right now, just ignore what I'm going to say. But there are a lot of organizations dealing with something that's very basic. That one of the problems is management can turn around and say, oh, you need super duper Maximo or some mega system that takes the next couple of years to get right, and you never do get it right. A computerized maintenance management system is not going to solve your reliability issues. If you're using it properly, it will aid the journey. If you're using it properly, you will capture the data that indicates how bad maintenance is, if I can put it that way, or how bad reliability is. You need at the least a simple system. And with that simple system, you can then learn about what you need to then get a better system. So you can do work orders and assign work to people and check that work's being done and generate reports and so on. And there's other things you can do. Right. In an ideal world, we would have the most accurate and up-to-date master asset list or equipment register, asset register, whatever you call it. We would also have a management of change process. We would have workflows for everything, procedures for everything, bill of materials. We would have everything. And all those things would be great. But while you're inside trying to do all those things, equipment's failing and we need to do something about that. But the one thing you do need is a master asset list. You need to have an accurate list of the equipment you have in your plant. That is just one of the sort of foundational pieces of information. So for right now, we're going to do that. And the equipment should be named logically. And this standard is a great standard to help you do that. Okay. There's lots of other things we could do, but that's, as we mature, as we start to get reactive maintenance under control, we can deal with those things. I do believe, hey, I'm a trainer, I always believe in knowledge. It helps to know what you're ultimately going to want to achieve, because that helps explain some of these things. It also helps you start collecting the data you need so that you can do those things later. You do need to start recording all your failures and as much information about your failures. It's just that you need to do something about the failures, not just focus on just recording all the failures, which some might advise. Okay, the next step is basic PM optimization. Now, this is again where people get upset with me for saying what I'm about to say. In an ideal world, we could sit down and perform reliability-centered maintenance. We could do a very detailed analysis of all the equipment in the plant and truly understand what their function, the failure modes, etc., etc., etc. And that would be wonderful. But that can be a very time-consuming process. It can take people away from dealing with the equipment failures that we are experiencing. There can be situations where the information that you require you don't have, and then at the end of it all, you end up with this great big massive report with all these things you should do, and then nothing happens with that report. There's nothing wrong with RCM. It's all about the implementation. So what I'm going to say is that if you are truly drowning in the reactive maintenance cycle of doom, that your place to start would be preventive maintenance optimization. The thing to understand is that you are right now more than likely performing a bunch of preventive maintenance tasks because of warranty requirements or for whatever reason these things have been introduced over the years. Those tasks are wasting your time and potentially causing the failures that you are experiencing. It's true. There will be maintenance tasks you simply do not need to do. There will be maintenance tasks that are duplicated. There will be inspections, check the pump, Well, in this case, hey, the pump's missing. Well, just as well I checked. But for the most part, people walking around ticking boxes and doing this sort of thing, it's like, what am I doing? People should be dealing with the problems, not recording the problems. OEMs can put together all kinds of recommendations for the things you should do. And while you're in warranty and while you're sort of new to this, you may not be ready to challenge those OEMs. There's a lot of OEM requirements that are simply unnecessary. It's a long story. But for sure, anything that's out of warranty, you need to sit down and say, we need to start again and really question things. The fact is that anytime we do an intrusive inspection, for example, we increase the likelihood of inducing or causing a failure. How many times have you gone into a shutdown, you go to start the equipment again and it fails? It's like, why did that happen? So often we do work that's unnecessary or intrusive, inspections, opening the equipment to inspect components and so on. And it just creates more work. It reduces the reliability. We need to make sure we only do what is absolutely necessary. We open up the gear to do an inspection and oops, I dropped my hammer. Okay. So there's two ways to do this. One is to go through this preventive maintenance optimization process. This is a starting point. We need to, as quickly as possible, stop doing what we shouldn't be doing and start doing what we should be doing. Now, again, RCM can make sure that you know what you should be doing. It can be a very time-consuming process to get to that end point. Anyway, I've said enough about that. But there is a way to do an accelerated RCM to just focus on the critical equipment, just focus on the troublemakers, the equipment at the top of your bad actor list, and do something about that first and analyze that first. We must stop doing what is the tasks that are wasting our time and inducing failures. We must focus on the bad actors and the critical equipment and make sure we're doing the right things. Again, all these topics, I would love for us to have lots more time to talk about them, but we've only got an hour. Now, one of the keys to breaking out of the reactive maintenance cycle of doom is to have effective planning and scheduling. We need to have somebody who says, right, we're not going to wake up in the morning and find out what work has to be done and pick and choose which jobs we'll do and wander out and do those jobs. Find the tools, find the parts. Oh, we don't have the parts. We're going to order the parts. When are the parts available? Well, we can expedite them. Oh, that's expensive. So let's keep more parts in our inventory. Oh, that's expensive too. And then when we take the parts off the shelf, how come this is all dusty and rusty and it's got spiders living in it? Oh, it'll be fine. Just put it in. We don't want to order another one. I mean, there's just so many problems with the situation we have now. We must fix those problems. So we will have an asset strategy. Whatever comes out of that PMO and accelerated RCM process will be the beginnings of our asset strategy, deciding which inspections we should be performing and how to perform them, deciding which condition monitoring tasks we should be performing, which proactive tasks we should be performing, and which time-based tasks we should, time or production cycle tasks. We need to understand those things, but we need a way to manage our work. Now, if problems just keep occurring every single day, all we really want to aim for is just plan so that we know what we're doing tomorrow. We would like to finish today with a plan for tomorrow. Now, I know the books say, oh, you must plan a week in advance or maybe 2 weeks in advance, and you must have, I mean, that would be wonderful, but it's not reality, not for companies suffering from reactive maintenance. If you could have a plan for tomorrow and people operations, production, maintenance, they shake their hand in the morning, right, this is what we're going to do. You'll make the equipment available. This is what's going to get done. This is what we're deferring. We're all in agreement. right? Good. Now you can't do that if maintenance and operations are, arguing at each other all the time and disrespecting each other. That's why we need that cooperation. So we need a planner, job planning 1 day in advance, wherever possible, making sure that the right person does the right work at the right time. That person should have the skills, should have the tools. So we will work on training and making sure that people do understand the skills they require. I will get to that. But someone needs to plan the work. Number one, planned work is much more efficient. We will get more work done with the same people when we plan it versus when people plan the jobs themselves. And planned jobs are better jobs. There will be less rework. They will be safer, and we'll get it done right the first time if we plan properly. Now, these things are going to grow and evolve and improve. We're not going to have procedures for everything on day one, but we're focusing on the bad actors and the critical equipment. We will develop procedures, put them in the CMMS, and grow bit by bit. We will find we have more procedures already in place. We'll have more skills, etc. We are going to grow our way out of this. Now, you might say, but I don't have a planner and we've got a hiring freeze, and where am I going to get a planner from? Well, what we're going to do is take another person off the tools. We're going to find a person, and you may need an electrical person and a mechanical person, but we're going to find a person who has the skills to do the majority of the jobs correctly. We need a person who is methodical, has a logical way of thinking about things, a person who has the right attitude, and that person will, from now on, be the maintenance planner. Now I'm suddenly hearing all kinds of screaming and so on going in the back of, so I hope no one's in trouble there, but anyway. Okay. So that person is now going to be a planner, and they're not going to be drawn into reactive work. Now, unless you've got a really small crew, that person must just focus on making sure that we are organized to do the work for tomorrow. And then as we go along, it'll be for the next day, and then we'll slowly plan further and further into the future. Now, you might say, oh, but you've taken 2 people out of my maintenance crew. We don't have enough people as it is. Well, if you keep doing this for long enough, someone in management will fire those 2 people anyway because they're trying to save costs. Anyway, the fact is that there is such an improvement in efficiency that, for example, if you had 40 people in your maintenance crew, if 20% is 8 people, so don't look at it as losing a person, look at it as gaining the effective work of 8 people. The time spent actually doing work, the tool time, if you like, will go up. And that's what we are seeking to do. We want people with the skills to do the maintenance work to spend their precious time doing the maintenance work, not figuring out what needs to be done and taking care of the safety and finding the tools and the equipment and wasting all their time doing that. Okay. Now, another thing that I'm going to suggest, and it depends on your situation a little bit, but potentially you could take another person out of your crew to do kitting and staging. Now, planning is great in that we know what parts are required, we know what tools are required, we have procedures to do the work correctly, etc., etc. But if the person then spends a whole lot of their time searching for those parts and then taking those parts out to where they're doing the job and so on, they are wasting their precious time. Instead, what if we take a person and say, we don't want you doing the maintenance work, we want you to make everyone else really efficient. So the moment that that plan is in place, between the planner and this person, we're making sure that the parts we need are available, the tools and so on are available. And the staging part is, if you've got a large facility, you take the parts into a secure, environmentally controlled area out near where the job's done. So now those skilled people who can install the bearing or install the motor or whatever they're doing, they just go out there and do the job. And what they need is ready. It's organized. The efficiency gains are tremendous. They get satisfaction out of doing the job right the first time and not standing waiting for someone who's searching around trying to find the right parts and all of that. Now, the further into the future you plan, you get greater and greater benefits out of this, because if we're just planning for tomorrow, then there's less benefit having someone doing this. If we're planning for the next day or a week from now, then, as part of the planning process, particularly if they're planning, knowing that a job's coming, thanks to condition monitoring, they can order the parts and make sure they're in inventory ready to go, well before we're actually scheduling the job. Okay, so again, it's all about efficiency. So here is one example. If you know your wrench time or tool time, and this is something, it can be difficult to assess, but you really need to know approximately how much time is actually spent doing the work versus moving from A to B, finding those parts, finding the tools, finding, the equipment and so on. But if the wrench time is 15%, you got 10 crew, that might mean you're only actually getting 24 hours of effective work in a week. If we can increase that to 25%, because we're improving our planning and we're doing the kitting and staging and so on, but we're doing it now with 9 crew, well, just the kitting and staging part, sorry, this is just kitting and staging. Now we're doing it with 9, we get effective 38 hours of work. So we took one person away and we're getting a 58% improvement, which is the equivalent of 12 extra people. It's like, wow, it's, I better do that math. Okay, bottom line is we are doing these things to make the people who are doing the work more efficient. They will get more work done. They will do a better job. We are starving the fire of its fuel. We are stopping future fires from starting, and it just gets better and better and better. Now, one of the issues we have is how the spares are being managed. I hope your spares management system doesn't look like that. There's, again, spares management is something we could talk about for a very long time. But number one, we need to go around and say, hey, who's got precious parts in their lockers, under their desks and so on? We need to just make sure we know what we've actually got. We need to have a good inventory of our spares. If we don't know what we have available, then when the planner and the person doing the kitting and staging says, we need these parts for this job, if they can't say, yes, we have them, and you're confident, then someone has to just go searching for it. And if it's not there, they have to order it. I mean, that is very expensive, and you'd be surprised how much money is being wasted in inventory, in spare parts inventory. But it's very frustrating. It's very time consuming. It's not the right way. So we need to have an accurate inventory so we know what we've got, where we've got it, and ensure that every day we keep that up to date. So no one uses anything without checking it out. And if you end up with spares, after a job and they can be used, they're in tip-top condition, then you check them back in. You must maintain the accuracy of the system. And there's lots of ways to do these things. We just don't have time to go into the details of it all right now. But one other part, which sort of comes into this, but I'm going to talk about it now as well. We need to make sure that the spares that we have are in tip-top condition. Now, if you've got a motor sitting on a shelf and it's in a humid environment, it's in a dusty environment, it's sitting on a shelf or sitting on the floor and it's vibrating, all day long vibrating because of local machinery, then when you take that motor off the shelf, it will not be in A1 condition. It will fail prematurely. So we need to, and maybe not right now, while we're dealing with reactive maintenance, we need to make sure that what we purchase is good. We need to make sure that what we ordered is what we received. We have to make sure it arrives in tip-top condition, and we can talk about acceptance testing, but again, maybe not right now. But whatever state it's in, it needs to stay in that state. So if you walk around as part of your inspections that we talked about earlier, if you walk around and look at the spares and you think, oh my goodness, it looks dirty, it's disorganized, we've got creatures living in it. Hey, we're storing some of it outside. It's like, well, of course you're going to have reliability issues. So we need to control access to the spares, and we need to take care of our spares, rotating shafts, making sure equipment's not vibrating, etc., etc. And this all comes down to this idea of basic care. We need to care for our equipment. It's not enough to just, purchase the right equipment. It's not enough to do precision maintenance work, which I'll talk more about in a moment. We need to take care of it so it stays in that condition. So this is where some of the proactive tasks come into it. And again, we have to make sure we have a person who does everything to eliminate the root causes of failure. Now, understand that unless you're in a very unusual industry, a lot of the root causes of failure are well understood. You know, I think I saw that Jim Fitch gave one of the presentations, and lubrication and contamination control is one of the root causes of failure. If you're not doing that properly, it'll cause equipment to fail. And there's lots of others. So you don't need to do root cause analysis at this stage. I mean, if you can and you can do it informally, terrific. But you need to take care of the obvious root causes of failure. And so keeping equipment clean and so on, and I'll get to those in a second, they will again starve the fire of its fuel. But again, we need that person we identified earlier to do the proactive tasks. The moment that person is just given a work order like anyone else, it may not be prioritized high enough. We have to say, unless the sky is falling, you must do that work. And by the way, the person doing that work shouldn't be the person who, what can I say, has reduced capacity, doesn't have the greatest intelligence or skills. You know, sometimes the jobs that are perceived to be easiest, the jobs that are perceived to be least important, is given to the person who is least able to do the more difficult jobs. We must take pride in the proactive jobs. The person doing the lubrication and some of these other tasks is extremely important. We must care for the equipment or they will fail prematurely. So lubrication absolutely is one of those areas. We need to correctly lubricate the equipment with lubricant that's not contaminated. We must not contaminate the lubricant and the components when we grease the bearings and when we dispense the oil, and we must limit the contamination once the machine is in operation. Contamination is a killer of machines. Not having enough grease or the wrong lubricants is a killer. So we need to do something about that. Now, again, we could talk about world-class lubrication. You may not be ready for that. I mean, everyone will benefit from it, but it takes time and money and resources. And so, yes, we would love to do it, but can you afford to do that at the expense of these other things? We have to get good in a lot of areas. Now, this is an area where we need to be very good. You know, the more we do in this area, we will have a great return on our investment. We are improving the future with a lot of the things we've been talking about. We are improving the future, which is good. Now, some might say, whoa, hang on, why isn't lubrication the first step? A lot of the things we've talked about, enable the lubrication function to work. They're organizational changes, they're making sure we have clean lubricant, they're getting the culture heading in the right direction and so on. You can start with this immediately for sure, but only if you're confident that you'll actually do it correctly and it will be sustained. But remember, the things I'm talking about are not sequential. That is, you don't do step A first, and when you think that's perfect, you move to step B, and when you think that's perfect, you move to step C. They do overlap. And in the book, I have this quite detailed chart, which is probably way too detailed, but I try to sort of show what should be done and when, to overcome these sorts of problems. Anyway, enough of that. But one of the other issues is just keeping equipment clean. Dirty equipment causes overheating, it causes contamination, and part of all of this is culture change. If you walk out into a plant and it's dirty and messy and disorganized, and the workshop looks like someone's just driven through with a bulldozer or something, it sends the wrong message to everybody. It looks like nobody cares. But instead, if you keep the equipment clean, not only will the equipment love you for it, everyone else starts to feel, oh, look, wow, somebody actually cares. We're actually doing something. It's a real visual thing, and that helps. But it's good for the equipment. It's good for the culture change. Now, again, these things are not sequential. There is overlap between them. We must make sure that the work we do, the maintenance work we do, is performed to the highest standards possible. So we need tools like precision, or for laser alignments, and properly doing balance jobs, and properly fastening bolts and such, and valve covers and so on. We must do it to the best of our ability. So number one, we need procedures. This is what it means to do it correctly, and everyone will do it the same way. So we have to determine what is the right way. What tools do I need? What skills do I need? And we need to start investing in those areas. And management might say, what? We're struggling here. We're not making enough. We're thinking about letting people go, and you want to invest in these tools? Well, if we had time to talk about the bigger ART process, part of it is culture change, but part of it is building the business case in the first place. That's where I'd really like people to start, to be able to justify all of this. So when you make these requests, people say, sure, yep, the costs of what we're talking about here are minuscule, tiny compared to the benefits. So absolutely you need to do them. But everyone must understand that if we don't do it properly, there will be rework. People say, we don't have time to do it properly. Well, then why is there time to do rework? No, we will do it right the first time. There will be one way to do things, and we'll do it that way, and we'll get it right the first time. People take pride in their work. We'll have good relationships with our operations, and they say, okay, I realize you're going to take a little bit longer to do precision alignment rather than just bolting it together, and if the shaft turns, we run it. There just has to be that understanding. So precision alignment is important, precision balancing is important, precision fastening is important. All these areas we could talk about for a long time. We just don't have time. Condition monitoring. Now, if any of you know me at all, you might say, geez, he's waited a long time to talk about condition monitoring. Now I'm going to say something again that's a little bit controversial. Condition monitoring is wonderful because we can see the future. We can say, wow, these problems are going to occur in our future. Now, again, it depends on your situation. But if you're dealing with people who are frustrated every day because of equipment that's failing, and you say, my handy dandy vibration system has predicted that in a year this bearing's going to fail, you might just get a bit of a blank stare, and as if to say, why are you bothering me with this right now? What am I going to do with that information? To start with, again, to start crawling out of the reactive maintenance cycle of doom, we just need to be able to see a little bit in the future so that when we're planning tomorrow's work, it's not just planned around what's failed, it's what's soon to fail. And as we grow and grow and grow, we will see further and further into the future. As our planning gets to plan more than a day in advance and 2 days in advance, when our spares management is improved so that they can order the parts they need and so on, condition monitoring will provide the intelligence to make the right decisions for the planners and spares management. But again, having the world's best condition monitoring program in a plant that doesn't believe in the philosophy, doesn't have good planning and scheduling, it's like, man, I guarantee you that a lot of what you're doing is just being ignored. And the relationships won't be great. So this is a way to solve those problems. So we want to see what's coming in the future so that we can avoid it, so that we can deal with it. But to try and at this stage become super experts at it and invest a lot of money in achieving that may not be the best way to spend your money right now. Okay. But remember, these are all overlapping. So yes, we need condition monitoring, but we'd rather have planning and scheduling. We want to do some proactive tasks. We need to do our PMO. We need spares management. It's no good talking about the future if spares management can't keep up, or if planning and scheduling can't keep up, et cetera, et cetera. So there are tasks we can perform. Visual inspections using pretty basic condition monitoring tools. Now they're basic and easy to use. That doesn't mean they don't give you a good heads up about problems, and you can use some consultants at this point. Get them to come in and survey the plants and so on. I need to hurry up, sorry. Your Pareto analysis and your criticality analysis tells you where to apply the condition monitoring technologies first. You don't need to monitor everything. You need to monitor the troublemakers so that you can see the troubles coming. Okay, so there's lots of things we can do. Operators can use some of these tools as well. So rather than taking people with, very good maintenance skills away from those tasks, operators may be available to perform those tasks. But there's lots of things that the operators can do. There's lots of things that others can do to, observe the early signs of failure. It's basic, but we're learning how to grow out of the reactive maintenance cycle of doom, and we can get consultants involved. Now, last but not least, you may have heard of 5S: sort, set in order, shine, standardize, and sustain. Now, you might think, whoa, he's talking about this fancy, my main point is this, that just as it's important to clean the equipment, it's important that our workshop is organized and clean and efficient, and then that our spares are clean, organized, and efficient. Now, if you watch our video, you can sort of read this, but you will get more work done and have a better attitude towards everything if the workshop is organized versus if it's not. So it's not the first thing we're going to work on. We've got other things to do first, but this will help for sure. And yes, you can use shadow boards. It's not expensive. It's easy to do. The only thing I ask is, if you're going to use a shadow board, just make sure you put the tool on properly. That stuff just drives me nuts. Anyway, but that's just me. Okay, so how will we break out? I've run my time, so I won't go back over a summary. I genuinely believe, and I've seen it work, if you take care of those things, you will start to climb out of the reactive maintenance cycle of doom. You can slowly get better and better in each of those areas, and you will end up with a reliable plant. You just need to take little baby steps to get there, but you need to take the right steps at the right time. So I apologize, I've spoken perhaps a little bit long, but please, any questions you have, and any questions we don't get to, feel free to email them, and I'm happy to reply to those emails.
Okay, this is Mina Solomon speaking. I'm very happy to attend your session, Jason, always. And we have some questions for you. We have to take some of them. Some of them are very interesting. If you don't mind, so I will read them out loud for you. So the first question say, can we focus at one item like RCFA method to eliminate the reactive cycle. Do you think this will work?
No. So this question might have come in before, at least I tried to make that point. You know, what I've seen with RCA, for example, is that people start spending some time to say, why did this failure occur? But that is a time-consuming process. And so often people start the process of trying to find out what went wrong, but something else goes wrong, and suddenly the focus is on that problem. And then something else goes wrong, and the problem is on that, the focus is on that problem. So often RCA jobs don't get done. And even if they come up with the root cause, they don't do anything about it. We need all these pieces in place so that we can do something about the eliminating the root causes of failure. But I could go through each of those areas and say the same thing. You don't want the world's best condition monitoring program if you don't have planning and scheduling and spares management, etc. You don't want to have, invest thousands and more in organizing the storeroom. I mean, that's great, but you'll have a great storeroom and everything else is in shambles. And we could go through each of those areas. I say you need to go from, whatever your current state is to good in all those areas, a little stronger in some, a little less in others, and grow from there.
Okay. We have a question that is repeated in different versions, so I will read one of them. So they thank you for the session, and they tell you that if you said that RCM is too exhausting and we don't have the resources, the time, and they are responsible for some assets, where do you think they could start and how they should do it without losing the management patient and give them some respectful output?
Right. Great question. Well, number one, I believe that all the areas I just talked about enable RCM, reliability-centered maintenance, to work. Because it's no good coming out with a report, and documented details on what must be done, which, as you know, is time-consuming, it's resource-consuming. It will take time. It's no point doing that if you don't have the planning in place to organize those tasks and schedule those tasks, if you don't have the good relationships, if people aren't able to do those jobs correctly. It's no point identifying where condition monitoring is needed if you don't have some condition monitoring skills, and so on and so forth. So what I would say is that you perform the criticality analysis and the bad actor analysis, and even if you don't have great data, there's a way to do that, which I am at great pains to explain in the book. But perform that RCM work on your most critical assets, on 20% of your most critical assets and the top 10 bad actors. Start there and say, these are the things we must deal with now, and slowly work further down. If you have RCM skills, then you can also perform an accelerated, a quick RCM to review the existing PMs you're doing now. So whether you want to call it RCM or preventive maintenance optimization, it doesn't matter. The fact is, if you review all the tasks you are doing, and you can say, right, we are going to stop performing the 30% of what we've been doing, 30, 40%, and then another 10, 20, 30%, we're going to change what we're doing. And we're going to add some extra tasks because we've done the RCM, on our most critical assets. So the sooner you produce something that is valuable and has an effect, management will love you. If you're doing all of these other things that I'm mentioning, you will have success with those tasks and those changes you identify. You must have all the pieces in place. You just don't have to be perfect in all those areas. You won't get there. And on the other hand, if you seek to perform RCM, a detailed RCM on everything, well, while you're spending that time, I don't know if you've ever heard the saying, Rome burns while Nero fiddles, or is it the other way around? You need to be doing something about the problems you're having, not just analyzing it, not just producing an RCM detailed asset strategy. Anyway, so I hope I've answered that question.
Yeah, this is fantastic. So we have two questions that I will also merge. So they ask about your most recent launch books, the ART and breaking out of the reactive cycle of maintenance and launching your reliability transformation, along with our courses from Mobius, ARPE, ARPA, and L. In reliability department, where should we start reading? What's unique at the book? And at the courses level, who should get what? So you could elaborate on that.
Okay, great question. The ARPA, which the A is for Reliability Advocate, that provides excellent general knowledge to open everyone's eyes to what this is all about, to understand why equipment fails and what we can do about it. We want to change the future. We want to see the future. We would need to learn from the past. So ARPA is an easy way to get started. Now, for people in management, for people who identify as being involved with condition monitoring, maintenance, or reliability, if they're not strong in all those areas, then that is a great place to start, and they can take that whole course. Other people in the organization may not be allowed to go through that entire course, but we have abbreviated, shorter versions of that course that just simply open everyone's eyes. It's the start of the culture change process. Now, if a person is in the reliability group and they have responsibility for things like RCM, RCA, if they want to make sure the condition monitoring program is set up correctly, if they want to make sure they're collecting the right data so that I can identify problems and failure modes, and if they are a reliability engineer, the ARPE, E for engineer, reliability engineer, that course is focused on that. That is a good detailed course that puts all those pieces in place but spends enough time. Is it the world's best RCM course? No. Is it the world's best condition monitoring course? No. Planning and scheduling. The point is, though, as I've said, these things shouldn't be treated as silos. They are all related to each other, and ARPE spends time in that area. L stands for Reliability Leader. It's the Reliability Program Leader. Somebody needs to deal with this like a business, like a culture change process. They need the reliability engineers to focus their time in the right places. They need management to be on board. They need culture. You need culture change. When I say culture change, people need to believe in the idea that they would all be better off if the plant was safer, more productive, had less maintenance costs, and so on. So the reliability leader understands how to develop the business case to get management on board. They understand how to implement this program. So whereas we talked about the control phase, the ARPL will understand all of the phases of the ART process. They will understand, well, I won't go into all those details. They understand the big picture. They understand the culture change part, the business case. They can manage the reliability engineers. They can hopefully make sure that people get the ARPA training that they need. Now, there is one book that on ART that summarizes the whole process. It goes through the 10 phases. It goes through, in basic terms, the 64 steps. It just says, this is the reason that we are recommending you do things in this order. Now, in my ideal world, even though what we've talked about today, the reactive maintenance cycle of doom, is a very important step to take, we have 3 steps before that, 3 phases before it: building the business case, dealing with the culture, and having an overall plan for this whole thing. So in my way of looking at it, you need to start at the beginning and deal with all the steps and all the recommended practices, so that when we start focusing on reactive maintenance, we already have a business case in place. We've got these pilot projects going. Hey, I could be talking about this forever. there is method to the madness, let's just say. We're not waiting a long time before we start dealing with reactive maintenance. In fact, we get into it very quickly, but we do it truly, truly, truly with our eyes wide open. Now, there is a book that's been published, which is on the first phase called the value phase, because I find that most people, when I say business case, they kind of shudder. You know, what do you mean business case? Finances. But trying to talk to the senior leadership of an organization about reliability and RCM and condition monitoring, you know, they have to prop themselves up so they don't fall asleep. They, you know, it's like, what are you talking about? I don't understand what you're talking about. All they understand is the business. They want more profit. They want it to be safe. They want to reduce their costs. They want to take care of their customers. So you need to translate all this reliability stuff into a language that they understand. And that's what the value phase is about. Now, there's also the book that I showed earlier, the control book, the Reactive Maintenance Cycle of Doom. And I'm almost finished a course on that as well. It'll be available soon. But that focuses on what we've talked about today. How do you do it? And I appreciate that some people will say, yeah, I know Jason says we should do the business case and all those things, but you know, I really just want to focus on the Reactive Maintenance Cycle of Doom. So that's why I created that book and worked on this course so that people could start there and have success, even though I think they'd be better off just doing a few other things as well. But anyway, now, in the meantime, I am working on books on all the other areas. There's some almost due and some with a little bit more work. But the bottom line is that what you learn in ARPE, well, let's just say that ARPA gives you the big picture. ARPE helps with all the technical side of it. ARPL gives you the sort of the business implementation, culture change, program management side of it. I'm not aware of any certification programs or anything there's anything like ARP, E, and L. Most of the certification programs are very general in nature. You know a little bit about quite a few things. And I'm sorry, knowing a little bit about quite a few things, I don't think will get you there. You will just be frustrated at not making progress. You will be overwhelmed when you think, oh, I've got to do all these things. You know, it's just, it is overwhelming. I've been in this industry since, you know, the mid 80s, and I've seen it over and over and over and over in every industry, in every country. We are, you know, I hate to say it, we're setting people up for failure. It's just not fair. So that's why I've spent a lot of time to try and lay it out step by step. This is what you should do. This is how you do it. This is why you should do it now. Don't go jumping ahead to these other areas because you're just not ready. You'll fall down the same holes that everyone has fallen down before you. Anyway, I could talk about that forever, but I know it's getting late over there.
Yeah, so we can take one last question, and I will email you the rest of the questions. So we have like 9 more, but I can email them to you with the context, and I'm sure you will answer them all. So,
sure. Yep.
A very interesting question. Some PMs are harmful, but they are required by local codes like high potential tests for electrical generators and other stuff. How you recommend to overcome this?
Okay, without getting into the specifics, part of the PMO process is to distinguish between those that are harmful and the results can be achieved in another way versus those that are harmful and they are necessary. Now, with the harmful but necessary, it can be difficult to do this if you're not very experienced in reliability. But what I would recommend is that you challenge some of those requirements. Again, when you have the sort of the knowledge and confidence. So stepping back a second, usually there's a whole lot of things you can deal with before you have to deal with this very small group. But since the question's about that smaller group of tasks, what often happens is regulators just don't know any better. manufacturing companies, the OEMs, often, and we train a lot of them, they don't know any better. There are a variety of reasons why these inspections and tests are required, and often they are not actually required, or there's another way to achieve the same goal. I mean, just as one little example, years and years ago, I was dealing with the US Navy, and they had the insurance company ABS said, you must do this, 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 and this. And it caused a lot of downtime, and ships were, in dry dock for long periods, had to cut holes inside the ships and do all this stuff. And we went to them and said, now, wait a second. We've got this terrific condition monitoring program coming. We can see problems coming. And when we're doing these inspections to find problems that aren't there, we know they're not there, we're inducing failures. So they said, oh, okay. They backed off and they said, okay, we can now go much longer time between those inspections, and we can defer those certain inspections, if condition monitoring says it's good. So, and you can find, for example, that insurance companies will charge a lower premium because they understand that their risks are lower. Again, this is about breaking out of the reactive maintenance cycle of doom. If it's truly reactive maintenance that's the problem, then these areas you may not be quite ready for. In the ART process, we get to that for sure. It's during the acquire phase, and we talk about, defect elimination and working with regulators and OEMs and so on. But if you know there's a way to avoid it, then you need to put a case to those regulators to say, okay, these tests will give you the same information, or these tests simply aren't giving you any information that's actually valuable because they're harming the equipment. If you understand it, you can put that information to them.
Okay.
Hopefully that answers the question.
Yeah, that answers the question very nice. Okay, thank you very much, everyone. Thank you very much, Jason. It's getting late in Egypt and early in Australia, so thank you for waking up very early to enlighten us and show us a new pastoral ability.
My pleasure.
Thank you, everybody. Yeah. Okay, and we will be in contact with you, everyone, after the conference. You will receive your certificates, and of course, we will email all the questions to Jason. He will spend the time he always do to answer everyone. Thank you, and have a good evening and a good day.
Thank you.
Bye-bye.